Okay, here is a problem that basically relates three different concepts together. And these are power, voltage, and current. And they are subtly different, but they're related. And I'm going to talk you through each one of them here, and then we'll get to the problem, which is down here, and we'll work through it. So power is basically energy generated per unit time. The most common unit is joules per second, otherwise known as watts, as in J.J. Watt, the lineman for the Houston Texans, and also former Wisconsin Badger. All right, voltage is given in units called volts. It has a pretty complicated unit definition here. It's kilograms per area, or I should say times area over unit time cubed times amps, or yeah. And then current here is basically just given in amps, and that's coulombs per second. Now, one thing about joules is that this is a unit of energy that is given by this relationship. So that's kilograms times meters over seconds squared. And wouldn't you know it, that if you combine all of this together, you are able to get the relationship between power, voltage, and current. And I'm not going to do that for you right now, but just know basically that it works out such that you get power equals current. I forgot to mention current, by the way, is usually written as I. So there's a couple different things that are written as I. Intensity is one of them. In this case, current is written as I. So generally when they're talking about power, when you see I, usually, I shouldn't even say usually, that's going to get me in trouble, but a lot of the time they mean current, which is an amp. So make sure you check that, I guess, if you're working through a problem and you don't know what I is. Make sure you check what it is, because it could be any number of things. Anyway, power is given by the current times the voltage. And so this problem down here, you basically need that equation to solve it. And so it says that multiple 100-watt desk lamps are plugged into an outlet strip. And this is powered by 120 volts. The circuit breaker will shut the circuit off when the current exceeds 20 amps. So how many lamps can you plug in? We assume before the circuit breaker shuts off. So, using what we know, that power equals current times voltage, we can pretty much just plug in these two values. So we plug in power and we plug in voltage. And what that's going to do is this is going to give us the current that runs through the circuit when there is a single desk lamp, because each desk lamp is 1,000 watts. So if we go 1,000 watts equal to I times 120 volts. We can solve for the current that runs through the circuit when there's one desk lamp. So, like this. And this value is 8.3. Repeating like that. And again, that's in amps because that is the unit of current. So now we want to know how many of those lamps can we run before we hit 20 amps, which is the max amount that we can get before the circuit shuts off. So each lamp is responsible for 8.3 roughly amps of current. So each lamp is 8.3 amps. Okay. And then we know that the max current that we can get through this circuit is 20 amps. So all we gotta do is divide this 20 amps by 8.3, and notice that these units cancel, of course, and we get 2.4. Now, you got to use your head here because 2.4, remember, what this is referring to is the number of lamps, n. How are you going to have 2.4 lamps? It doesn't make any sense. You need a fourth, or I shouldn't say a fourth, you need 0.4 of a lamp. It's just stupid. Alright? So use your head here. You don't actually want 2.4 lamps, right? Or you can't have 2.4 lamps. So it's got to be some whole number of lamps that is on either side of 2 and 3, right? So it's got to be 2 lamps, because this is the max amount of lamps you could have theoretically, 2.4, right? But you can't have 2.4. It's got to be a whole number, so you got to have 2, or you can only have 2 lamps. 2 whole lamps. Alright. So, that's the problem. Hopefully that was helpful to you. Let me know if you have any questions, if you see anything that's wrong, and until next time. Thanks.